8th grade. It's time for another video lesson. Today we'll be taking a look at lesson 6-5, graphing linear inequalities. Now a linear inequality is similar to a linear equation, but the equal sign is replaced with an inequality symbol such as less than, greater than, less than or equal to, or greater than or equal to. The solution of a linear inequality is simply any ordered pair that makes that inequality true. So when you're graphing linear inequalities, there are three basic steps. For the first step, just as with solving linear equations, you want to solve the inequality for y, putting it in slope-intercept form. The second step is to graph your boundary line. This is just like graphing your equation, using the y-intercept to begin the line and the slope to determine the second point. In solving a linear inequality, you'll use a solid line for your graph if it has a bar underneath it. So if it's less than or equal to or greater than or equal to, you will use a solid line. However, if it's less than or greater than, you will graph and connect the points with a dashed line. Finally, the third step. You'll shade the half plane above the line for inequalities that are y greater than or y greater than or equal to. And you'll shade the half plane below the line if y is less than or if y is less than or equal to. Finally, you'll check your answer by choosing a point and making sure that it makes the inequality true. Let's take a look at some examples. In our first example, we're simply going to see if the ordered pair is a solution of our inequality. So let's take the ordered pair -2, 4, excuse me. Try that again. Take the ordered pair -2, 4. This is an ordered pair, an x and a y. And we'll use the inequality y is less than 2x plus 1. To see if our ordered pair is a solution, we'll put in a -2 for x, and we'll put in a 4 for y. So this becomes 4 is less than 2 times our value for x, which is -2, plus 1. Now we'll do the math. So this becomes 4 is less than -4 plus 1, but -4 plus 1 is -3, and 4 is not less than -3. This is a false statement, so this ordered pair is not a solution. Let's do one more. In our second example, we're going to use the ordered pair 3, 1, and we'll use the inequality y is greater than x minus 4. So again, we'll put in a 1 where we see the y, we'll put in a 3 where we see the x. So that gives us 1 is greater than 3 minus 4. Okay, now we'll do the math. 1 is greater than 3 minus 4. 3 minus 4 is -1. 1 is greater than -1, so this is a true statement, and yes, it is a solution. We have not graphed, we simply put our x and y in to see if it's a possible solution, and we found in this case that it was. Now let's try graphing. So let's start with this inequality, y. Let me go to the next page. So I'm going to make an ordered pair. I'm going to make a coordinate plane. Of course, you'll use a ruler. Okay. Now I've got the inequality y is less than or equal to -2x minus 3. Let's think about the steps from our first slide. In the first slide, remember it said to solve for y, and we do have this inequality solved for y. So now we're going to graph the line. We have a bar underneath our less than sign, so therefore it's going to be a solid line. I'm going to begin my line by looking at the y-intercept, -3. So, need to extend this a little bit, and I'll put it out at -3. There's my y-intercept. My slope is -2x, so I've got a problem here. I need to extend my page. All right, so we've extended the page. I had to make the graph go down lower. My slope is -2x. That means I'm going to go down 2 and over 1 for my next point. Now I have 2 dots. I know it's going to be a solid line, so I will draw my line through my 2 points. It's a solid line because there was a bar under my inequality symbol. Now remember, the original equation was y is less than or equal to 2x minus 3. I have to decide how to shade my line. I'm looking at all real numbers less than or equal to 2x minus 3. On my line, therefore, I shade below. Remember, less than means below. So I'm looking at numbers below the line. To help you decide whether you're shading above or below the line, think of yourself as a skier going down the hill. Here you are, okay? So below the hill would be below the line, and above the hill would be above the mountainside or above that slope. That is the answer to our first inequality. To make sure that I've graphed this correctly, I will, oh, excuse me, it should be a negative sign right there. So to make sure this is true, I'm going to pick an ordered pair that I've shaded, such as this one right there. So this is the point -1, 1, 2, 3, 4. So -1, comma -4. I'll put that in. So that gives me -4 equals -2 times -1 minus 3. If this is a true statement, I've shaded in the correct direction. -2 times -1 is a +2 minus 3. I have a -4 here. I'm looking for the symbol less than or equal to. This is 2 minus 3 is equal to -1. So -4 is less than or equal to -1 is a true statement. So this is a solution. Let's try another one. So my second example, 5x plus 2y is greater than -8. Step 1, I'm going to solve for y and put it in slope-intercept form. So solving for y, I'll subtract 5x from each side, giving me 2y is greater than -5x minus 8. I need to divide by 2, which means I'll divide every term by 2, and I get the inequality y greater than -5 halves x minus 4. -5 halves x minus 4. So I'm going to make another graph. My y-intercept is -4, so I'll put it out at -4. My slope is -5 halves, which means I'm going to go down 5 and over 2. Again, I'll have to extend my page. All right, so I'm going to extend the graph. I have my first point. Remember, the equation was -5 halves x minus 4. I have my y-intercept at -4. I'm going to go down 5. 1, 2, 3, 4, 5, and over 2. Here's my second dot. Remember, there is no bar here, so it will be a dashed line. I have a negative slope. That means my line is going downhill. There's my negative slope and my dashed line. In this particular problem, I'm looking for numbers greater than -5 halves x minus 4. So I will be shading to the right. I'll be shading above the line This is above the line. Remember, here's the skier skiing down the slope, and he's above the hill. So this is above the line. So I'm shading to the right. Again, to check this, I'm going to pick a point that's in my solution set, that's in my shaded region. So I'll pick the point, I'll pick this point right here, which is 1, comma, -3. I'll put that in my equation. That gives me -3 is greater than -5 halves times 1, which is -5 halves, minus 4. -3 is greater than, this is -2.5, minus 4. -3 is greater than -6.5. This is a true statement. That means I've shaded in the correct direction. Let's try one more. So this equation, this inequality, we're going to start with is 4x minus y plus 2 less than or equal to 0. I want to get y by itself. The simplest way to do that is to simply add y to both sides. That gives me 4x plus 2 is less than or equal to y. But I like to have y on the left-hand side. So therefore, I'm going to flip the whole thing and write y is greater than or equal to 4x plus 2. So think about it. When you flip it, the arrow is pointing to the 4x plus 2, so it still needs to point to the 4x plus 2. Here's my inequality. I'm going to draw my graph. My y-intercept is at 2. Let me back up. Let me count by 2's here because, well, here, let me draw my x-axis again. All right, so here's my x-axis. That'll be better because then I can do my slope. So my y-intercept is at 2. My slope is 4, so I'm going to go up 4. 1, 2, 3, 4 over 1. Oh, there's my second point way up there. I'm going to use, yes, I'm going to use a solid line because there is a bar underneath. So connect my dots with a solid line. Okay, now I have my line. I need to do my shading. In this particular inequality, I say y is greater than or equal to 4x plus 2. So I will shade above. When y is greater, you shade above the line. So if I'm the skier, I know above the line will be where I am skiing, above the snow. Here is my shaded portion, and this goes on. All of this is shaded. Okay, so there's my solution. Now to check my solution, I'm going to pick a point that's in the shaded region. I'll pick this point right here because I can identify that. This is the point -1, comma 2. I'm going to put that in my solution. I'll put a 2 in for y. I'll put a -1 in for x. So that's 2 is greater than or equal to 4 times -1 plus 2. I will simplify. 2 is greater than or equal to 4 times -1 is -4 plus 2. 2 is greater than or equal to -4 plus 2 is -2. This is a true statement. Therefore, I know that I have shaded in the correct direction. So these are the basic steps for solving linear inequalities when we have one inequality in two variables. Tomorrow we will be taking a look at how to do some examples here. You'll be doing some work in class. So be ready with your notes. Make sure you bring your notes to class. Thank you and have a good evening.